Welcome, everyone, to Teach Me PCB. I'm Mark, the creator of Teach Me PCB and co-facilitator of this year's course, along with my friend Jesse Robinson, who I think is going to join us tonight. We're already joined by This is Paul Daly. You'll never guess what his name is. And Brian Lindahl of Lindahl Engineering. Welcome, gentlemen. How are you?
Okay.
All right. Good talk. Good talk.
It's been a long, stressful day on the parent care front. So,
I'm sorry.
I'm kind of twitching.
That's tough, Brian. I'm sorry to hear that, man. Anything we can do to support you?
Not unless you can convince Medicare to extend the deadline for the signing up for next year's supplemental insurance plans, which was today.
Oh, no, I don't have that kind of link.
Oh, come on.
But
you know a guy,
I do know a guy. Have you considered reaching out to your local senator or congressman?
Not yet. We'll see how things go, but
it's very good to stay involved in politics and get to know your congresspeople. So.
I don't know. I don't want to know them too closely. I'd be more tempted to shoot them or something. Sometimes. Not now.
With the Nerf gun, of course.
Yeah. Get the stream flagged right away.
Well, Paul Daly, man, we've seen you in the forums. Tell us a little bit about yourself and what you're doing down there in Costa Rica.
Yeah, so I come from Michigan Tech. I'm wearing a Michigan Tech shirt right now, and I have an electrical engineering degree from 2018. And then I spent the following 3 years working at Plexus Corporation. It's a pretty cool place. They do contract design and manufacturing. So a company comes to us with an idea or product, and then we make it happen and we manufacture it. That's the goal. We could just do any part of the product development cycle, but the idea would be the full cycle. It was a really cool job. I enjoyed it a lot. And I was a digital hardware design engineer. So I did a lot of schematic capture in that role using Cadence and other tools. But yeah, now I'm in Costa Rica. I got married over the summer, and my wife had a great opportunity here in Costa Rica that just fell into our lap August 9th, and September 1st we moved here. So we found out about it August 9th, and 3 weeks later we were here. So packed up everything. Yeah.
That's pretty crazy. So you're working remotely then, or?
I am not. So I quit my job, and I found this course through an advanced assembly Facebook post, and I said, well, that looks like a cool continuous education type engagement. Shows that I'm doing something.
Do you still feel that way?
I think this is a great course. I enjoy it. I hadn't done a whole lot of the PCB layout aspect. I mean, I've supervised some layout reviews, and I've kind of said, hey, I think when I made the schematic, I feel like this component should be near this one, that kind of stuff. But to be in the tool, I haven't really used KiCad a whole lot, other than a few hobby projects that were quick Gizzy boards, 10, 15 connections, and connector saver type things for test equipment.
Have you been able to get the parts, or do you need me to ship you a package down?
So I actually am going to the States, so I'm going to Detroit in like a week or something. I filled out that form. I don't know if you don't recognize my name, then I got to order some parts. But DigiKey was really fast, so I ordered some key switches last night or a couple nights ago or something.
Okay, so I haven't done any international shipping.
No, I'm Detroit, Michigan. I filled out an address for my in-laws' house.
Okay, so every United States, some Mexico and some Canada addresses were fulfilled. They should actually be arriving tonight, tomorrow.
That's awesome. Well, I ordered a soldering station and a refill gun to be shipped there too. That's my Christmas present.
Oh, sweet.
Everything is in storage units right now, and I was like, well, I could probably assemble this over Christmas break. We're going for a week up in Detroit. So.
Oh, very
Yeah.
cool, man. Well, I'll have to make sure I get the videos organized then. But I did videos on how to assemble just, everything by hand. So, and I did that, by the way, with this board right here, where I installed every LED backwards, all of them. So,
Good
because
for
the pin
you.
number 3 is marked.
who does that, Paul? Who does that? Monsters.
Yeah.
Well, it's not just those, because the reverse mount ones are the same way.
Yeah.
I read that it's actually the data sheet's confusing, so I'm hoping that they're the same way, because that's how I marked it.
Yeah, I have a Hackaday article open right now with your complaint about pin number 3.
So now I've got to desolder all of my switches, and then desolder all of those LEDs, and ain't nobody got time for that. I'm just saying.
I've been soldering. My other little project has a string of 20 NeoPixels that are the little individual circuit board that they call buttons, which have 6 tabs on the back to tap to stick wires to. I was soldering those all day and managed to get half a dozen of them backwards, even though there's nice little arrows pointing the data path direction. I still got some backwards. So I feel your pain.
Don't even sweat it, Brian. Half of all LEDs, I would say, at any assembly shop are put on backwards, at least. So don't even sweat it. So
I'm worried enough about the diodes on my key matrix on this board, making sure that they're pointed the right way when I get them.
Well, what can I do for you guys this evening? Did you just stop by to say hi and chat, which we can do? Did you have questions about DFM? We can do that too.
Well, I know you're offering limited support on the diversions of schematics, but I wanted to just kind of look at my schematic for a quick sanity check of
sure,
if that's an option.
It is, of course, it is. So yeah, when I say limited support, we want everybody marching down the same path. And Hector, we see that you've joined us, but we need your camera and audio on. So we're still waiting on that. That's on your end of things, my friend. Anyhow, we want everybody marching down the same path, at least on this first design, because if you let everybody make their own schematic, it becomes really a one-on-one tutor situation, right? And we don't have the staff for that. It's basically Jesse and I as, facilitators / instructors. And if everybody does their own thing, there's no way for us to keep up. But if everybody does mostly the same thing, we can totally keep up. So let's give it a shot, man.
Yeah, so I was trying to follow some of those threads in the Discord about the WS2811s. So using the LED driver instead of the one that's specified for the encoder. But I took it a step different. I left one of the encoders able to be using the original spec SPI, the SPI LED driver.
Okay.
So can I share a screen? Is that an option?
Yeah, absolutely. Right. There should be a share button down there. Yep. Once you share it, Brian will bring us into the mix. And Brian will probably go Shift 7 for the layout for picture-in-picture.
Boom. I think I'm sharing my KiCad schematic view.
Yep, we're bringing it in now. Okay, and then
it's not the prettiest view.
That's okay. I've got to look at a different screen so I get a large view of it. So I'm not ignoring you. I'm actually looking at the laptop.
Well, here's the trick. I only have a laptop, so I only got one monitor. I can't see any of you right now.
Don't even sweat it. I'm just keying up. Okay, so
I have my Pico in this main block here, and I've got 8 key switches. I have 2 sets of LED strings, a RGB driver, which we'll burrow into that in a second, and then I've got 2 encoders on my board.
Okay, give me one. No, can we go back for a minute?
Yep.
Just give me 1 minute more to get up to speed.
So out from my Pico, I have 8 key switches, and then I had kind of started to name your things, and I was like, well, they're not the best naming conventions. So I have 2811A and 2811B, along with left Neo 3v3 and left Neo out 1 wire. All of those are the same function.
What's wrong? Oh, well, that's okay.
Yeah.
No, but the only thing about a naming convention is as long as you're consistent on the sheet, we're good. Okay. I'm with you. So, go ahead.
Yeah. So this pretty much follows the same business of what you got, the level converter into a sheet of LEDs. So nothing too crazy there. I am using 2 sets of these. The shape of my board, I don't know if I can even... Can you view... Do you see the board right now, or do you see just the schematic?
Just the schematic right now.
Okay, let's... Oop. Did I stop sharing? I think when I... Yeah, okay, hold on a second. Hold on, I want to share...
Stop sharing.
No, I don't want to stop sharing. I clicked something off, and that's okay. Whatever.
Oh, okay.
We'll just focus on. I was going to pull up the board view, but I think I only shared just a schema and not the whole screen.
You can do it. We're not in that big a hurry, Paul. If you want to figure it out.
I was just going to give context to what the board looks like and why I did instead of 1 string of 16 LEDs, I did 2 strings of 8. But
is yours kind of a chevron pattern like the?
Mine is the Majora's Mask. If you look up Legend of Zelda Majora's Mask, it was a game for the Nintendo 64, and it's got all the little pointy things out the side. And I put the key.
Do you want me to pull it up? I think I have it.
No, I'll just hit stop sharing and reshare. How about that?
Okay.
Stop screen and. Yeah. Okay. Yeah, we'll just go like that. Now you should have my whole screen.
Yeah.
So, this is
very cool, by the way.
Yeah.
I think it's kind of neat. And I really appreciate. I'm just using the 3D files or the step files that were available in the class pack download. So I understand that the switches don't have the LEDs like this and whatnot, but it's somewhat representative, or that these are not the real encoders, but the idea is there. So I've got these LEDs along the top here. I didn't have room to put them underneath the keycaps, and I thought it'd even be cooler if I could program the encoder to like the level of volume or screen brightness or something, have that shown on the LEDs. Could be something neat. Yeah. And then I've got the mask on both sides, but
that is really cool.
It's kind of nifty. But that's what I was looking at. And then so that's just like the overview of like why there's 2 strings of LEDs. But what I was really trying to look for was the craziness going on here. So I have 2 encoders, and what I ended up doing was I have for LED driving B, which is the right side, I have connected both the WS2811 and the NLSF 595 to that driver. And so that's kind of in this area. So if I unfill, edit.
And you're going to select which one of those is active with some jumpers, I assume?
I was just going to populate which one. I don't have any jumpers in there. But
no worries. Just wanted to make sure you're not doing or people out there in TV land don't think you're using both.
Yeah. So this is, I'm going to populate one or the other, but I was kind of thinking you were suggesting like, hey, let's get a spy device in here. And I have no qualms about putting a spy device on one LED driving and 2811 on the other.
So the reason that I do that is so that I can talk about a very popular serial communication methodology. You do not need to stick with it. If especially since the NLS F595, it doesn't have any sort of internal drive circuitry, right? You have to keep repopulating that from the software size. If you want to just cut that out, you are not going to hurt my feelings. I doubt that if this course repeats, I doubt if that IC survives. Be honest with you.
Okay. Yeah.
So
it's already routed. I mean, it would clean up a little bit, but it's on there. It's not going to hurt anyone. Yeah, and it made it easier to route, because originally I had it down here in the center, and then I was branching a whole bunch of traces up, and now I could probably even put these all on the top layer. I have almost everything routed on the top layer, and then I used I think layer 2 is, I should redo my pores, and then I think layer 2 is a ground layer, and layer 3 I have as, it's a little carved up here, but I think the top part here is 5 volts and the bottom is 3 volts. And yes, it looks a little funky, but I just kind of went with it. It matched it.
Okay, so all your signals are on the top layer, which means they're going to couple to layer 2, as the return path. So who cares what's happening on layer 3? Because it will also couple through the other dielectric to layer 2. So that split plane thing, I mean, who cares? I mean, you're worried about it being carved up? Man, I would not at all.
Well, yeah, originally I was trying to do something funky with a whole bunch of nodes and try to make the eyeballs so that the board is pretty much hollow at where the eyes are in the mask, so that the LED will shine through. And then I just remembered I could just make a zone that is a keep out for solder mask and or for copper, and so that's what I ended up doing. Is I just made a circular zone that is a keep out. So yeah, it's cool.
Okay,
but yeah, I think really my question, and it's kind of been answered, was, is it cool enough to just do this? And am I implementing the 2811 correctly? I know that there's supposed to be like a resistor and a capacitor here for power line filtering, but I think that in Discord I was pretty much convinced that I probably don't need it. I'm knocking on wood.
Okay, so what I'm trying to teach in the course, and this is something where Jesse and I, we go back and forth on this weekly, right? I want to teach best practice, things that will keep you out of trouble always, right? That's what I try to teach. But that being said, if nobody was watching, you would not see me do a lot of the things that I do in class. But you kind of have to know what the rules are before you decide to break them, you know?
Yeah.
If you knocked off half of the capacitors off this board, you would not see any performance decrease. However, your board would be less likely to pass EMC testing.
Yep.
Okay, well, nobody's ever going to EMC test these boards, ever. There's just no reason for it. However, if I don't teach you that, and then, you go out and you get a job and you go do something, you're like, well, Mark said this, and it becomes a thing. So yeah, you can get away with much less capacitance. The 10 microfarad that I used, those could all be ones without anybody noticing, especially with the tolerances that capacitors have. You can get away with much less in the way of decoupling capacitance at the expense of noise. So
Well, cool. Yeah, I have done a lot of noise tracing and trying to find possible EMC related issues. Ironically, I just made it my desktop background. That's a micro section of a 30-layer PCB with an ultra scale FPGA on it, and there was a tiny fracture that I predicted between this ball and the thing. It's not a microscope picture. This is a crummy phone picture from a few years ago, but this is pretty cool. But we were trying to track down an EMC problem, and we found a solderability problem instead.
And you were able to predict it?
Yeah, well, we had some high-speed link tests that we were doing between the FPGAs, and we could get bit error. We had a bit error rate, and we saw this bit error rate becoming higher and higher, thermally related, or we predicted that it was going to be temperature related, because as the system ran longer or got hotter, it had more errors. And it ended up being this huge investigation. We did a thing called the shadow moire, which is like you look at the chip and how when you're soldering it, it kind of bends into a smile versus a frown or something. And you can measure the amount of variance it has at the edges of the chip versus the center. And then you had to calculate the density of solder balls at the outside. And so your stencil for solder paste became more solder on the outside of the edges and near the corners where there was peeling away, and less in the center. And it's a really expensive problem, and it was a lot of fun.
Do you have that written up anywhere?
In internal documents that, I used it as an internal training exercise for my last job.
Okay. So that would be a good article for my friend's journal, Eric Bogatin. I'm sorry, Dr. Eric Bogatin.
I know Dr. Eric Bogatin. I have his textbooks.
Yeah, let's talk offline. I would love to connect you and see if that's something interesting to him. So we've been privately just emailing back and forth about warp lately. I've been talking about board warp, but I think he would be interested in chip warp as well.
I don't want to take all the credit for that. There was a team that, like, I was highly involved in this discovery and in this process, and I went to the manufacturing site where we were doing our failure analysis and that microsection. But I do want to say that a huge amount of that credit goes to a gentleman named Dale Lee, and he was an IPC President's Award or something, Founders Award last year or something like that. He won an award from the IPC. He did a lot of that contribution, and I believe his work in that is going into writing. As a company, we learned a lot about that board and that process, and then that work went into feedback for the IPC. So
the way that you generally do that, if you haven't published before, is you would just cite them as an additional author.
Yeah.
Right? So you would write it, since you're the one writing it. You get to decide the order of authors. Usually the person who contributes most, whether they write it or not, becomes author one. And then, you can quote other authors in there as well. But I think that is a significantly interesting problem and solution that it might be worth writing up if you want to. I don't want to push you down that road if you're not interested.
We'll check in a year or so. I have a year to return to Plexus, and I still get my seniority. And so if I'm back at Plexus within a year, I'll have all the resources and stuff, and I can talk about making it a white paper.
Okay.
But I'm staying at a high level of, like, I can definitely talk about this stuff. Like, I have that picture, but it would be a lot cooler if I can get more detail from that.
Fair enough.
Yeah.
So, all right. So our friend Hector, who we still don't have your video, my friend, otherwise we'd have you on screen with us. And he just sent something related to that.
Mm-hmm.
Okay. So he's got a question regarding what you just said. And I'd like to do that first because it's relevant, and then I want to address his question. He says, did you predict a crack pattern on your board? And then a big O underscore little o.
That's the face. So what we did was we had several of these boards. These boards cost a fortune. They were really, really expensive, had a high failure rate. They were using the top of the line ultra scale FPGAs and had a lot of this design was not done by me, but they had like 100 gigabit per second links. It was a supercomputer, and we could test these boards, and several of them had like failures, and we just we looked at the failures and the bit error rates, and we were like, well, okay, we can map it and see where the failures are happening on each board because we have all these prototype boards, and we're like, okay, they're all happening clustered near the corners of the chip on the links, and we don't know which FPGA it's talking to or which link it is, but it's either this pin or this pin on the BGA, and they're both in the corners. So we just decided to tell the customer, hey, we need to sacrifice a good board right now, and it's got one link failure, and it's either on this pin or this pin of the BGAs. We're going to slice them up, figure it out, and we're going to follow every via and stuff along that link, and then identify it. So did I predict the crack pattern? We took all the data we had, we plotted it onto as if it was all just one BGA, and we saw that all the dots were near the corners. And then it was a lot of characterization and soldering.
Very cool. How many layers was your board?
It was 30 layers. It was 3 10-layer laminates then laminated together. And they were just ridiculous amounts of ounces of copper.
I can imagine. Yeah. Wow. All right. So let's see about Hector's question and see if we can answer it for him. I'm wondering if you... Oh, by the way, Hector, if you type your comments in YouTube, they come straight in. If you put them in StreamYard, it goes to a private chat, but it doesn't matter. I'm wondering if you can talk about how you design a micro, buried, and blind via. How do you calculate the drill and pad diameter? How is this done out there in the industry? I've tried to find any formulas for this. I've searched even IPC, but I couldn't find any analytical methods for this. Do any analytical methods, or I'm sorry, does exist any formula for this at all? I did read that right. Okay, I just thought I didn't. So I can help you out with that. Don't design a buried and blind via unless you are doing a 1,000 board run or a 100 panel run. Here's why. It changes the way that your boards are built. Now, if you make one board or even one panel, all of your NREs, your non-recoverable engineering, it's going to get absorbed into that one board or that one panel. Maybe it's $5,000 extra dollars. I don't know. Let's call it $5,000 for the first panel. Now, you get one board out of that. You've just added $5,000 to your board cost. It's ridiculous. However, most of the NREs are just first-time upfront costs. Then it's just a little bit extra each panel. So maybe it's $5,000 upfront cost plus $100 each additional panel, right? Okay, well, now it's not such a big deal, especially if you spread that cost out over, 1,000 panels or 10,000 panels. Now maybe you're looking at $50 extra per panel rather than $5,000 for the first one. Does that kind of make sense so far? Well, I can't actually talk to Hector, so I don't know why I'm asking. Yes, that makes sense. But anyways, so for small jobs, something where you're not making a bunch of boards, do not design blind and buried vias. Now, as for what the limitations are, whenever you call out a drill size in a fabrication shop, let's say you want something to be made, I don't know, 1 millimeter for your via. Well, they don't drill 1 millimeter. They will actually over drill the hole and then plate it back down to 1 millimeter. So they'll, depending on how much copper you're going to plate onto there, they'll drill it to 1.05 millimeters or 1.1 millimeters. It all goes in 0.05 millimeter increments, and then they will try to plate it down as close as possible to your final dimension, if that's something that's important to you. The critical things, typically you want an aspect ratio no greater than 10 to 1. So if you've got 3 millimeter, let's call it 0.05 millimeter dielectric thickness, you don't want any more than 0.5 millimeters diameter for your drill. That's the 10 to 1 ratio. As long as you stay below that, plating's easy peasy and everything. Now, as far as equations and all that sort of thing, a lot of what you might be looking for will be covered in IPC 2221, and some of that has actually been replaced by IPC 2152 as far as trace and all that business. But really, what people have found is that, maybe you're worried about running high currents through. Well, the via temperature is going to be, I can't think of the right word, but it's going to depend on the trace temperature above and below. The via is not going to get hotter than the traces above and below it. Otherwise, copper is so thermally conductive, it's just going to suck the heat right off of the via and out into the rest of the board. So you don't really need to worry about it. And if you're looking for a reference on that, look for Douglas Brooks, Brookes. I want to say his website is UltraCAD, ULTRACAD, and he actually just republished a book on PCB via temps and trace temps, if you're worried about it from a thermal aspect. Artech House Publishing, ARTECHHOUSE, they'll have his book. Amazon's got it as well. I don't know how I did answering your question, but hopefully you'll let me know. Paul, did you want to add anything to that from your design experience?
Well, you're right about the back drilling and the micro vias being a pain in the butt. That's for sure. I tried to use in a college project the NRF 52840. That's a Nordic Semiconductor Bluetooth 5 chip. It had just come out, and I got an engineering sample to try to make a Bluetooth USB dongle with. It called for micro vias or via in pad, and KiCad is not equipped for that. So that project, we tried to use the entirely out exterior pins, and it just was not a great project to work out. But shortly thereafter, they came out with like the NRF 5210 or something, or 810, which is designed to be on 2-layer boards and in cheap toys and electronics. So that's a cool part.
Nice. Yeah.
Good Bluetooth 5.
Very cool. Yeah. One of the funny things, since it is kind of the week of DFM, errors that would really be assembly errors, like having a V-in pad that's not plated over a VIPO. It's one of those errors that's very easy to slip through because your PCB manufacturer simply doesn't care. You can have vias in pads. That's not a DFM problem designed for manufacturability. It is a design for assembly problem because all of your solder is going to get sucked into those via the barrels, and it's going to leave your pad. It's called wicking. Now, your assembly house isn't going to pick that error up either, because when you do a DFA check, you don't send them your drill files. Your assembly house has no idea whether it has no idea where any of the holes on your board are, any vias. So it's one of those things that's really, really easy to slip through, but then you're kind of out of luck. You've sent a board to the assembly house that they can't assemble because all the solder is going to wick away. So then what do they have to do? Well, they have to sit in there with, little tiny scissors and little tiny tweezers and little pieces of Kapton circles and, turn your board into an arts and craft project. No good. So, all right, Hector's back. Yeah, that makes sense. I didn't know the NRE for a couple boards. It's so high. That's a thing to consider. Now I'm seriously thinking of use through hole vias instead. Yeah, use through hole vias. And I don't know the exact NRE costs. That will vary from board house to board house, but it's non-reoccurring engineering fees. And they show up once when the board house has to figure out how to make your design and set up special jigs, that sort of thing. And once they create those jigs and once they create the design files, they don't have to do it again. But the only way then for your project to be affordable is if you spread that out across many, 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 many boards. So
I'll throw one on there. The other thing is,
Sure.
if you're going to use microvias, try to not. Okay, if you have like layer 1 to 14 or something like that, if you're going to use microvias at all, try to make them all the same layer jumps. If you don't want to have like layer 1 to 3 and layer 1 to 14 and layer 1 to 6, if you can make them all go from like 1 to 6 or something, then you're minimizing the amount of extra process that goes in. There is like NRE costs. At least some board houses that I've dealt with have had to, or they add extra costs if you're doing microvias to different layers. So if you're going to have them at all, just make them to the least amount of layers you have.
Interesting. That will very much depend, I would say, on your board fabrication technique. Like you said earlier, you had a 30-layer that was really 3 tins that were probably connected with transient liquid phase soldering paste, right?
Yeah, I think so.
Yeah. So you really want to have those conversations with your board house on what you need, where you need it. But you're absolutely right. Minimize things whenever possible. I've seen people run, they've got different impedance controlled layers that, traces that they want to run. Oh, well, they'll run their 90 ohms on layer 2, couple back to layer 1, and they'll run their whatever on layer 7 and 8. And it becomes this huge mess of back drilling and it's all unnecessary. Just adjust your trace width. But have those conversations with your board house on what are creating the cost drivers for your circuit and how you can avoid them. So thank you.
Do it early so you don't end up designing something that they then want to charge you for and you have to redesign, because that also gets expensive.
Yep. Very good advice, Brian. Well, welcome to Andrew and Scott.
Hey, how you guys doing?
Good. How you doing tonight?
All right.
Doing good. I'm trying to stop tinkering with my board, so we'll see if this works.
I found the best way to do that is to package it up and order it.
Yeah, I think you might be right.
Then
I
if you
accidentally
have something
stayed up.
wrong, then you fix it.
Yeah, I accidentally stayed up again to I'm not going to say how late I was up last night, but I was up late last night working on it because I lost track of time.
It happens, especially
It's
new,
fun.
it's exciting, it's fun. Yeah. It is. It's totally fun. But yeah, one of the articles I wrote over it, all about circuits, I found a quote about writing, and it's something to the effect of, a project's never finished except through some accident, such as, a deadline or death. Or something. So, Scott, I think it's your first time here. How you doing, man?
Okay.
Welcome.
How are you guys? Thank you.
Good. Welcome. What can we do for you, gentlemen, tonight?
I just finally figured I'd join and show myself to everybody since I've been hanging out on the YouTube channel and watching things every week. I finally got a chance. I'm not working tonight, and figured I'd join.
Hey, we're happy to have you. Can do you mind telling us a little bit about yourself and that beautiful condo you're in back there?
That's the virtual background.
Yeah.
So, yeah, I'm a systems administrator for a hedge fund in the New York area. I'd been doing PCB stuff on and off since college. I went for electronic design and programming and fell out of it for a while. I got back into it because I'm involved with Scouts and they have a robotics merit badge, and so I signed up to be a counselor for that, and taught the kids how to create a robot with 2 degrees of freedom, and mostly it was line following cars and that kind of stuff we did. I kind of got back into doing things and just kind of learning more and more about PCB design and getting a little bit more involved with it. And I saw the course and I said, hey, this looks like a good opportunity to actually like see what I've learned and learn some more stuff, which I've definitely done. So definitely cool. I appreciate it.
Hey, we're happy to have you, and I hope you found the course useful.
Oh yeah, definitely. Yeah, definitely learning a lot of stuff. Maybe
Well, good.
little things here and there that you didn't think about, or even just something like, wow, I never even knew about that. So definitely good.
Well, good. Well, hey, have you guys all gone through the DFM with me so far? I kind of lose track of who's done it and who hasn't.
I don't think I've gone through that yet.
So yeah, so one of the things that we have for you is a couple free DFMs. Basically, send me your files, and I'll run them through a program. And we're looking for problems that might exist in your design. The DFM isn't perfect. It's flagging some things that aren't really a problem, and I don't really know yet how to get it to unflag them. But yeah, send it to me. I'll run it through the program, let you know if there's any issues, and we'll have a little back and forth that way.
All right, yeah, I've been working on it. I've kind of fallen behind because I started this new job when the course started, so it was kind of able to keep up at first. Now I'm knee deep in things, and it's getting harder to keep up. But hopefully, I can get a design to you soon.
Yeah, life is always the trick, and it sounds like I need some more realistic time estimates for next time through. So
yeah,
absolutely. Andrew, how about you, man? How'd the DFM go for you?
I think DFM went pretty good. I know I had you run through it a couple times for me, and that was helpful. I think one of the things I kind of noticed, and I think you're sort of asking questions, and then reading through this week's information. So I think that to the point, the EDA only does so much. It's not going to catch everything, and I think that that's kind of like the challenge of just like understanding how to lay stuff out. I went back and watched the videos from last year. That was kind of helpful. I think I'd kind of done some of those things accidentally, but it's sort of helpful to sort of like solidify that. But then having the DFM report and being able to go through and tweak a couple things to make that hopefully more manufacturable, I think was helpful and good and a good exercise for me. So all in all, I'd say good. I just wish the iteration loop was a little bit easier.
From my side of things, or from which side of things?
Oh, no, not from your side. Just from like I like being self-sufficient. So like I would love to be like within KiCad and like be like click the button and have it like do DFM and be like, oh yeah, of course, duh, and like iterate like that way rather than having to send it off to someone else and have it go to like another. It just is interesting that it's not necessarily like all in an integrated system that and I get why for like there's a lot of legacy behind that.
Yeah.
Nothing from you. It just I wish that when I did like design check, it would do all of that other stuff too.
Okay, so it is possible, although not on the current server that we're using, it is possible to automate the DFM process. So you could turn in your board and like a minute later, get the DFM report.
That's cool. And I think part of it is also just like coming from a world where, having done like continuous integration, continuous deployment type systems where, in some ways, like you write code, you commit it, you check it in, it goes through an integration process automatically in the background, and it tells you right away, yep, you're good to go for pre-flight, and then it launches it. So I think, it's not a big deal. It was just sort of a disconnect, I guess, of what my expectations were.
Yeah, I hear you. It would be nice if the EDA software had a more robust error check built in. But absent that, I think that if we do decide to keep going with TeachMePCB, that is something where we could absolutely automate it, where I don't need to be involved in the process. Turn in your file, it checks it, life moves on. So, well, cool. How's everything else going? I feel like I'm talking too much.
Yeah, everything else is going good. Parts should start arriving for me soon, and then I'm gonna get this shipped out. I was gonna try and wait to get some feedback, which I think might not be completed until a week from today, if I read the schedule correctly. Yeah.
So it is spaced out because you took advantage of DFM last week.
Yeah.
Right? You've already gotten like 3 DFMs back.
2, but yeah.
Okay. So you've already gotten 2 DFMs back. Most people, their first opportunity for that is going to happen tomorrow morning, right? They turn in their files today. I've already generated some, returned them, other people. So you're a little ahead of the game, but really, if I remember correctly from your board, the only issues were like silk screen, being a little too close to some pads. You could order your board now. You don't need to go through this other stuff.
Okay.
But other people, like, Scott said he's still got to lay out some stuff. I think I heard Paul say that too. He's still got a little bit of layout left to do. So realistically, we're kind of into the spot where people are going to order their boards. Their parts should come in today, tomorrow for the ones that I mailed.
Yeah, I got mine today.
So
thank you.
Oh, you're welcome. So, we're going to get back together and do the board bring up and programming and whatnot in January, but we're kind of getting into the wind down phase for this course, So I forgot what my point was.
Submit. I think the point was go ahead and order now. I think
Yeah, you can order now. You can absolutely order now. And Scott, what'd you think of those pictures, or not the pictures, but the stickers I put in there for you?
I love them. I got them sitting up on the side of the monitor right now.
Great, man. Great. So what else can we do? What else would you guys like to know, talk about?
Yeah. I'm unmuted. You're good? You can hear me?
Yeah, you're good. We can hear you.
Okay. I was looking at my job report, and I have a minimum clearance same net, DFM level elevated, and I think this is what you were saying is I probably routed all the ground traces and then did a pour. Is that's what that error is?
Yeah.
Okay.
Well, it can be a lot of different you've got to, once you get an error, you have to look at the reason behind it. So for example, if you route ground traces and then you do a copper pour, you've got 2 geometric images that are going to be overlaid one on top of another. It's going to generate an error, but does that mean that there's an error? No. Is it an issue? It's not really an issue. Those two things are going to short circuit, but they're supposed to short circuit. So it's one of those things where the software is not yet sophisticated enough to look at something like that and ignore it. Pretty much everybody who used KiCad who imported something from Inkscape is getting an error that, whatever feature is too small. It's like 0.4 millimeters. I forget. But really what that is that they imported an edge, and that edge has a line width associated with it. It's not really an error. It's just triggering the DFM software. So once you get an error, you have to go back and look at it and see, is that really an error? You have to use your noggin a little bit.
Is there, and this is probably getting a little bit deep, but it sounds like it's all just, a set of rules that the system goes through and checks. Are there efforts into doing like machine learning as part of DFM that you're aware of, or is DFM kind of considered a solved problem?
There are efforts at machine learning. I remember reading about some of those 1 or 2 years back. It's not that it's a solved problem. It's just looking at it from 2 different ways. So inside your EDA software, before you export any files, everything is a set of geometric shapes, right? There's lines, there's rectangles, there's things. And your software has to go and look at things that are very, very well defined. Now, once you export, life changes. Instead of a trace being, let's say a line or a whatever, it turns into these things called apertures and flashes and decodes. So y'all 3D print, and you know what G-code looks like?
Yeah.
Pretty much everybody? Okay. It's a set of, move from x equals 0, 0, 0 to, move to the right 3 inches, move up 2 inches, move to the left 3 inches. That's what happens when you generate your Gerbers. And apertures are, they're sets of relative code, things that are repeated over and over again. So in normal code, you say, move from x 3.2, y 4.3 to whatever. Well, in the apertures, you say, well, move to the right 0.3. From wherever you are, move to the right 0.3. From wherever you are, then move up 0.2. From wherever you are, then move left 0.3. So you can set these images that show up in lots of different things. So like on the Pi Pico, where we've got a 40-pin thing and they all have identical pads, you would create one aperture file, and then you would define the center of that aperture, and you would say, drop it down in all these locations.
It's like a macro with relative coordinates.
Exactly. Yeah. Exactly. So the DFM is looking at the results of that. So where your error check is looking at the original design files, the CAD/CAM files, the DFM is looking at the G code, and it's looking. They use different sets of rules and different programming. I don't think anybody would say it's a solved problem. It's an evolving problem. It's just one where there aren't a whole lot of people working on it. So UCAMCO.
Evolving because the machine tolerances are getting tighter and tighter, so you can do more and more, or why is it evolving?
Okay, so the driving factor are the IC manufacturers, right? They want to put more and more chips onto an IC, a wafer, because then their cost per IC goes down, right? The more things they go up. So they keep shrinking and shrinking and shrinking and shrinking. And that gives us smaller and smaller and smaller packages. Now, that's all well and good for the IC manufacturers, but fabrication has not kept up. We don't have the technology yet to do all those things. So if you take a place like Royal Circuits, where we are heavily invested in buying the latest, greatest machines each and every year, so that we can keep up with that, that shrinking size. Our DFM rules are going to be different than, say, South Coast Circuits, which is actually a company we recently acquired. And they're doing test equipment stuff, automated test equipment. Different machinery in the shop. So then we have different minimums, different types of boards that we're making, right? ATE, you get those thick 30, 96 layer PCBs that you just don't see on the 2 and 4 layer. It's one of those things where not only which shop you go to, but which assembly line in a shop, you're going to get different rules, different capabilities, and different yields. So
Okay, yeah, no, that I guess that makes sense. It's technology continues marching forward, and so things have to catch up and keep up.
yeah, and where you are in that acquisition phase of the newest, latest, greatest materials, it's going to depend on what your rules are.
Another question I had was, in watching the videos from last week, it looked like they had some test points that were added. Do we need to have test points on ours?
No,
Okay.
but just so you know, the reason that we did that, we have partnered with Fixture Fab. That's one of our sponsors. So they're going to join us on a webinar on the 16th and show us, if you did want to have test points on your board, how you would incorporate those, what the best practices are, and where you go from there. So if if you're making something like the Adafruit macro pad, right? You probably want to ship that out the door programmed. And maybe you don't want somebody sitting there and plugging a USB in. Is it that big a deal? It's not that big a deal. But it's a whole lot easier if you can pick up a robot, drop it onto a pad, program it, pick it up, send it off to shipping, pick up the next one, wash, rinse, repeat. So no, you don't need test pads, but we're going to show you how to use them in case you want them.
Okay, cool.
Adafruit does all of their testing that way. They have little test jigs with pogo pins. They take the board, stick it down on it, push a button, and it programs it, tests it, says if it's okay or not, and they go to the next one. It's
and I think
fascinating to watch.
Yeah, and I think SparkFun does do. I mean, it's been a decade since I toured them, but I remember seeing the little jigs they had. It was pretty cool.
Yeah, for those of us that do one-offs, it's not worth designing a test board. But if you're making, 50, 100, 1,000, 10,000, 1,000,000 of something, you sure as heck want to incorporate those practices in your design. Because nobody wants to touch 1,000 boards to program them. So, yeah, it's good questions. Scott, Brian, Paul.
Yeah, you were talking about the warnings on the silk screen. That's a comment that you made on mine, and I was just sitting here looking at the silk screen, and there is nothing unreadable or too small or faded out because it was thin or anything. I'm not sure which things it was that it was bringing up, but there sure aren't any issues that I can see. Yeah, I look at everything that's supposed to be there and it's there. So
the DFM that I ran with just the default values that came with the software. They're not programmed to any specific manufacturer or any specific manufacturing process. There are two ways that you can silk screen a board. One is traditional, direct legend printing. One is the I don't know if you guys have ever seen silk screen, but you basically put a silk mesh down with a pattern on it, and you force ink through with a squeegee. The other way you can do it is with it's like a laser printer, except it spits out ink, little blobs of ink.
It's a big inkjet.
Yeah, it's an inkjet. So each one of those ways has different resolution associated with it. The forcing it through the silk, through the mesh, you can have smaller features at increased cost, because again, now you've made a template and now you need somebody to sit there and do it, versus the other way where you're printing with, blobs. The silk is going to be a little thicker, but there's no setup costs associated with it. You just put the board down, off you go. The DFM that I'm using, nobody's paying attention to what process is being used. Nobody's paying attention to what manufacturer you're using. If you're using JLPCB, PCB way, They might have different requirements. Royal might have different requirements. So look at the errors, then, use your best guess if it really is an issue or if it's not. So all of the errors, by the way, that it's showing, silk over pads or silk too close to pads, nobody is going to put silk on your pads. The manufacturers will delete all that stuff for you. Won't even be an issue.
Will they have to manually go in and actually erase that area, or is it just an automated thing where it's just like, okay, here's a pad, just get rid of the area above it?
Yep, that's exactly what it is. It's all automated. So part of the software just says if there's, silk within 3 mils, 4 mils of a pad, cut it out, delete it.
Okay.
And I did see in the plotting function on KiCad or KiCad that you can uncheck a box or check a box that'll remove silk from pads. But I also saw that after my resubmission with that, I still had errors with silk over pads, and they were just really tiny nothings of a marking on the pad, but it's there. It's probably just an approximation error or something.
Yeah. So that kind of thing you would look at and you're like, that's not really an issue. Ignore it. The deal breakers, the things where you really do have to stop are you short circuiting? Do you have 2 nets overlapping that shouldn't be? Are you dropping down below your trace space minimums for your copper weight and fabrication house? So if you've got 2 mils of space between 2 adjacent nets, they're either going to upcharge you a lot, or you could have a short circuit. Those are the things where you really need to worry about. But silk in the wrong spot, not that big a deal.
Could you talk about the different surface finishes? Like when I look at the different companies that do PCBs, some of them are, and excuse the toddler in the background, but some of them are like ENIG, lead-free, hassle with lead. There's probably some other ones. Does it make a big difference for what we're doing? Are there pros and cons? Yeah,
Okay,
I mean, I just don't know, so I don't even know what to ask.
Absolutely. So you can't leave bare copper on a board. The simple reason is oxygen will very quickly bond with the copper. And once it does that, there is no way that solder is going to stick to that oxidized copper. So you have to put something down. The cheapest and probably most fragile is OSP, organic solderability preservative. You basically just take the board, you dip it in a tank, it leaves a chemical on it that blocks the oxygen from reaching the copper. The trouble is it's only good for about 6 months, and it's very, whatever the opposite of scratch resistant is, it's that. It's very susceptible to disturbance from any physical motion. So that's OSP. The next cheapest is Hassel, hot air surface level, and that comes in lead and lead free. Essentially, you take the board and, for lack of a better descriptor, you dump it in a tank of hot molten tin or tin lead mixture. By the way, we don't dip these things in. That's not the way we do it, but just to give you an idea. And then you take an air knife and you shoot it down both sides of the board, and it blasts it off. Now, it's cheap, which is good, but it's also not very flat. So then if you want to go and you put a solder stencil on there, the solder stencil is not going to lay down flat on your board. So you try to push the stuff through, it comes in too thick in some spots, too thin in others.
And
right?
that's like the surface tension of the tin when it dries is why it's not flat, or is it just this?
Lost my audio.
Yeah,
liquid?
it when it dries, whichever way, if the board's pointed down, you're going to see blobs all in, or whichever way the air knife goes over
in the corner. Yeah, okay.
it's going to end up in the corner. bigger pads might end up with more on them. You know, there's a few different reasons why. And again, you can get that in lead or lead free, just depending on which kind of processes you plan to use further on down the road. So that's HASL, HASL, hot air surface level. Next up, you've got ENIG, electroless nickel immersion gold, right? Yeah. Okay.
Yeah.
So electroless nickel, we're still taking your board and we are in fact dipping it in a liquid, except we're not hooking it up to anode and cathode for a power supply. We're letting essentially an autocatalytic reaction occur where you've got the nickel and it goes and it attaches itself, 1 or 2 atoms thick, or maybe 2 or 3 atoms thick. I don't really remember. But it'll stick to the copper layer and protect it. Now, nickel will still oxidize, so you can't leave it by itself. So then you have to put it into gold. The gold is great because it doesn't oxidize. You can't put the gold right on the copper because if you do that, then you end up with, is it purple plague? I don't know. Basically, the gold mixes with the copper and it can cause a failure. I forget exactly which one right off the top of my head. So that's ENIG. And then the last one is INIPIG, electroless nickel immersion. Let's see, electroless nickel, electroless platinum immersion gold. Basically, you're doing the same thing, but you're putting down a layer of platinum, a couple atoms thick, and then a hard layer of gold. And you use that type of thing for like wire bonding, that sort of thing. Typically, when I order boards for me, I use ENIG all the dang time because then you can, use a stencil, you can use a solder paste printer, do whatever you want. Since we are assembling these things at home, we're just recommending the HASL finish, hot air surface level. If you're going to do lead solder, might as well use the lead HASL. If you're going to use lead free, you should definitely, you don't want to start mixing solders.
And
Does
then,
that answer the question?
yeah, well, and I guess then I was going for like a particular look where I was going to get like a black PCB. If I want like a gold or that gold color, I need to use the ENIG though. So if I use the HASL, that will be a silver.
Yep.
That's correct.
Okay, everything will. Yeah. Okay. Cool. All right.
And just as to go back to what you were saying, Mark, they do still dip. That video that they had of that crazy guy doing the tour at JLPCB.
Mm-hmm.
Even their new equipment, they were dipping with a vertical hot air scraping as it came back up out of the dip. So that was a very fascinating video, just thinking about it, that my board had come from one of their factories. I don't know which process they used for it, but it was a lot of fun to watch.
Yeah. Well, the other way that we do it too, you'll do like a wave reflow where you'll, instead of, okay, so if you do dip it, right, you need a big tank of molten lead that's circulated and it takes up some amount of space. The other way that you can do it too is have a much smaller tank of lead and you create a little wave and you pass your board over it horizontally. That's the other way it's done. So just depends.
It fascinates me watching the videos of the various solder processes going with pumps and fountains and waves and stuff. If I was designing something like that, it would plug itself up every 10 minutes and be not a commercially viable thing. It just wouldn't ever work. I can guarantee it. But just watching those things work is just, how is it doing that?
My wife thought I was designing this and then printing it on my 3D printer in my garage. So I had to show her, oh, no, I can't do that yet. Unless you're authorizing me to go spend a lot of money. Yeah. But yeah.
I keep seeing the commercials. I can't remember the name of the product. Is it Volterra or something like that? It's a little desktop fab. It will draw traces in conductive ink it'll do your silk screen and solder mask and everything, right there. If you're doing prototypes all the time, it would pay for itself so quick, I think. But
Volterra is pretty cool.
Not for a home shop. I can't see paying that much.
See, I don't know. I don't know if it would. I don't know how much the Volterra costs, but I know how fast we can make boards. And I have to think that if you're in the situation where you need your board back 8 hours later, why not just pay to have it done by somebody who knows what they're doing, instead of, I don't know. I'd have to go look at these things and see what the state of technology is. But with as small as components are getting, I just don't know how people are keeping up with it, right? We have chemists on staff who are going out and checking the tanks hourly. How are you going to do that if you're doing this in your own engineering shop?
Yeah.
And
I can only barely imagine doing pick and place with a 402 resistor. How the heck do you even hold on to the stupid thing and pick it up and put it where it goes? That's an order of magnitude beyond what I can imagine mechanically. So yeah, it pays.
Yeah. And here's the other thing too. Okay. So our webinar Thursday, we've got a guest who does PCB cleaning, right? That's his whole business, is PCB wash machines. And he recently did some research, and they found that if you are under the peak reflow temp by as little as I think it was 0.5% of peak reflow temp, you're going to be leaving all sorts of contaminants on your board that are going to affect the long-term reliability. I don't remember. It might have even been less than that. I don't know. We'll find out Thursday. But I was looking at that. I'm like, my toaster oven reflow, there's no way. Maybe I get within, 10 degrees of my reflow profile, if I'm lucky. There's no way I'm getting within, half of a degree,
I mean, I think that if you had a good enough controller and a good enough sensor and a good enough recirculator fan, you actually could probably, even with a toaster oven, I bet you might be able to get within a degree.
No,
you don't think so?
I don't.
I'm being.
They're so imprecise. The whole thing with the heat cycling in a with a small heating element. A home oven, when you're cooking with it, you're lucky to be within 25 degrees at any one time because it's chasing the temperature. I can't see the little toaster oven. I know how badly they toast. I can't imagine that they'd be any better at making a PC. Doing a reflow.
Let me follow with this, Andrew. So what we do whenever you order a board, right? Let's say you order 5 boards. Royal ships 6 or 8. And what happens with those other ones is they become solder samples. We will actually sit there on your board and attach thermocouples all over the place and send that through the reflow oven and track and then start adjusting, individual zones on the board,
right?
As long, as well as individual zones along the way.
It's the saturated. And this is the same thing. We have the same issue with when we do environmental testing so we use DO-160s for aerospace, and so you actually have to put thermocouples on the device you're testing, and then make sure that the device is fully temperature saturated, or alternatively they just make you wait 3 hours, which is how long they figure it will take for enough temperature penetration to occur to make the item under test at the correct ambient temperature for whatever your test you're doing. So I get that I do get. Yeah.
So, I mean, it's all fascinating stuff. So we'll find out more Thursday. And then,
so on your toaster reflow, are you using a separate controller to control the profile, or are you just using the one built in and you're just timing it on a stopwatch?
I haven't built it yet. You can kind of see the parts box up here, right there. I've got all the parts to make one, and it's got a separate controller and a thermocouple. Maybe there's two. I don't know. But there's no way that it's going to compete with the equipment that we send through our reflow ovens with every board.
Oh,
There's just
yeah,
none.
absolutely. Yeah, yeah. No, I agree with that.
So now, and again, we'll find out Thursday, right, you need to be within 5 degrees. Okay, I can believe I can maybe do a decent job at home. It's going to take me some time, but I could do it. If you have to be within half a degree, no, not happening.
And I think that the issue is it's not half a degree of air temperature, it's half a degree on the board, which is what you're talking about.
I'm going to find out Thursday, so I don't want to overstep. I don't want to overstep because I wasn't able to attend the conference where he presented this, so I just remember it was a really low number, and I'm like,
really scary. Yeah.
And because I remember just being like, it was either like half a degree or 0.5% or something. It was something incredibly small, and I'm like, there's no way. You just got to send it off to, a house, a CM every time.
I think you had said it was a half a percent is what I remember in one of the other sessions or online that you said.
That could, that's kind of the direction I'm leaning. It was small. It was really small. So, all right, gentlemen. Well, any other questions? If not, we'll let everybody get on with their evening.
Thanks for the fun and looking at the schematic. I might jump the gun and order soon.
Once you are okay with the DFM and you've said, okay, those aren't really problems, it's probably safe to order.
Yeah, I just during the call scrolled through the whole list, checked out the different spots on there, and think I'm okay. Okay.
Well, hey, don't go away too far. We still have some exciting stuff. We do have Duncan Lauder and Joe Selvik of Fixture Fab coming up on the 16th. We've got Mike Conrad on Thursday, the 9th, I guess that would be. We will do some firmware programming stuff over the holidays, a little more informally than we have been. And then once, everything's done and everybody has their stuff, we'll be back at the beginning of January with some board bring up sessions, and we got to show off what everybody made and talk about where our problems were, what we can do better next time. I do think this course went a lot smoother than last year. I'd like next year's to be even smoother still. So, hey, I appreciate everybody's time. Do you guys want to do this again this week, or?
I'm probably going to order. So, I mean, I'd try and join just because I enjoy chit-chatting and asking questions, but I don't have a need to.
Well, hey, I enjoy talking too. We could do like a Friday, or what works for you?
I will. I'll have to look at my schedule, and I'll send you something on Discord.
Okay.
I don't want to overcommit.
No worries. Well, we can do this again if we want to. But it really is a pleasure seeing everybody. We've got a comment. Oh, that's the Volterra V1, $4,200. That is a pricey little booger, isn't it?
But they've made it pretty simple and straightforward. One of the ads I keep seeing on YouTube is they sent a box to their marketing director who had no idea how to make a PCB. He was a marketing guy, to unbox it, put it together, and use it. And he was able to. It was well packaged and well designed and well documented enough that he was able to actually get good results, even without being an engineer to do it. So it's a lot of money, but I could see doing it if I was designing stuff all the time, having a board in an hour instead of a day. Maybe.
One that's a lot cheaper than the Volterra. It only does like 1 or 2 layer boards or something, but it's the other machine company, Other Mill, and I think they were acquired by someone, and so I don't know if it's still called the Other Mill, but you can search it and find it, and it's a little three axis mill or something, and it can do your small PCBs.
When you're actually milling traces, you have a lot higher you've got to have fatter traces and a lot more space in between, so you can't do some of the smaller stuff like ended up on my board. But yeah, that's a way to do it.
Yeah.
I don't know. I think I'm still ordering offshore for the foreseeable future. But I'm at the point now where I'm doing a board a year. I'm not churning out high volume of anything, So, all right, gentlemen. Well, thank you so much, everyone who joined us this evening. I do appreciate your time. And I look forward to seeing you in our Discord or in our forums, if they're even still alive. Although the good news is, thanks to some pushing from our friend Elliot, we've got forums that are going to last for
A while.
years, really. It's so much better than what we did before. So unfortunately, we kind of disincentivized people from participating in the forums due to their poor design before. So I don't know if we're going to get many people back, but we'll get there. Anyhow, thank you everyone for joining us this evening. Thank you to our sponsors, Royal Circuit Solutions, Advanced Assembly, DigiKey. We've got OshPark, Walkwe, and theanalog.io, the best newsletter that you need to read. We just had another episode out today, another version of it. If you haven't already, please subscribe to Advanced Assembly's YouTube channel. We'd love to have more people there. I'd like to get up to 500. So if you have already subscribed, consider sending it to a friend. We've got some good content. And with that, we're done. So thanks everyone for joining us on Office Hours. Hope you all have a great night, and we'll see you later this week. Bye.
All right, everybody.